Okay, today we'll be covering 1.3 applications of quadratic functions. If you look around you, actually there are many examples of quadratic functions all around the world. For example, if you look right, in this case there's this ship that's spraying water into the air. If you can just use a bit of imagination, you notice that actually, hey, the water actually follows the path of a quadratic equation, okay? Similarly, if you look at bridges, all right, many bridges have this shape, okay, whereby this is a quadratic equation, this is a quadratic equation. Or if you've been to Universal Studios, any other amusement parks, you'll find that, hey, you notice that the shape of the roller coaster itself also follows the path of a quadratic equation. So today for this section, what we'll be doing is we're going to talk about how we can actually apply mathematics, right, and these quadratic equations in real life itself. So I'll cover now example 11. So example 11 talks about a ball that's launched from a slingshot. It's given that the height above the ground is given by this equation. So if I were to draw a path for you, okay, a quick sketch, right? This is a slingshot here. It will actually launch the ball. The ball will go up and then it will come down this way. So this is the path of the ball itself. The path of the ball follows this equation, okay, whereby at different values of x, okay, you can find the different values of h itself. So this is the equation for example 11. So now find the height of the ball above the ground when it has just left the slingshot. Okay, so now the key word here is just left. So when it has just left the slingshot, what I'm trying to find here is this. When it just left, where is the ball? The ball is down here. And I know that at this point here, my x value is equals to 0. It hasn't moved yet, okay? So down here, my x value is equals to 0. So given that the equation is h equals to negative 2x squared plus 8x plus 1, what I'll do is I will let x equals to 0. Because the ball is still there at x equals to 0. So I can find my h value. I just substitute it into the equation. I find that my h value equals to 1. Oops, made a mistake there. My h value is equals to 1 meter. So it implies this from my diagram. When my x value equals to 0, I substituted into the equation here. I found that my y value is 1. It means that the ball is 1 meter above the ground, okay, when it was just launched. Okay, part 2. Find the greatest height of the ball when it's launched with a slingshot. If you look at this, what we're trying to find is this point here on the graph, the greatest point. So as you have followed in the previous lessons, this point is known as the maximum value. So how do I get the maximum value here? What I can do is to use the completed square form of the equation. So very quickly now, by using completed square form, I can easily read, okay, the height of the ball. So I will start with the equation. Remember, if I want to complete the square, the coefficient of x squared has to be 1. So I get x squared, okay, minus 4x, okay, here will be minus half. Then my h value, I complete the square, x minus 2 square minus 4 minus half, minus 4.5, so it's minus 9 over 2. So very quickly now, if I multiply the negative 2 in, my completed square form gives me this. So this implies that my maximum value or maximum height is 9 when my x value is equals to 2. But in this case, they did not ask you what the what I call the value is. But if you want to label it on the graph itself, I know that this maximum point is when x is 2, my y value is 9. So I can quickly answer the question that my maximum value is equals to 9 meters. Okay, part 3 is talking about if a toy is 3 meters horizontally from the slingshot and 7 meters above the ground, justify if the ball will hit the toy directly. So basically what this question is trying to say is, does the path, okay, of the ball cross 3, 7? So I repeat myself, does the path of the ball, okay, that is launched, okay, from the slingshot, does it pass through these coordinates in space? When x is 3, h is 7. So what we'll do is this, I will use my equation again, h equals to negative 2x squared plus 8x plus 1. So what I'll do is I will let my x value be 3 because I'm trying to find out if it passes through 3, 7. So when my x value is equals to 3, what I'll get is my h value is equals to negative 2 times 3 squared plus 8 times 3 plus 1. My h value is 7. So therefore, actually on this graph itself, I find that it passes through. So the ball, okay, will pass through the coordinates 3, 7. Hence, okay, it will hit the ball. The ball will hit the toy. Because this 0.37 satisfies the equation. Boy, hit the toy. Okay, now I go on to try 11. So try 11 is here. Okay, you can read it by yourself and then you can pause the video to try. I give you the answers in a short moment. Okay, 3, 2, 1, and here is my worked solution for try 11. So when the projectile just left the catapult is 0 meters away from the catapult. So that means, right, it's at x equals to 0. So basically, again, same idea here. So what I'm trying to find is when my x value is equals to 0, where is my projectile? Okay, so I will just simply substitute it into equation. When my x value is equals to 0, I find that my h is 3. So therefore, if I look at my diagram here, my h value is equals to 3 when my x value is equals to 0. So it means that the projectile is 3 meters above the ground, okay, when it left the catapult. So the catapult actually is down here. Now, next thing is this. To find the greatest height, same idea here. What I can do is to complete the square. I will leave it to you all, okay, to see how I completed the square. But if I read, right, from this, what I call completed square form, I find that my turning point is equals to 107. So that means when x equals to 100, my height is 7. So therefore, the greatest height was 7 meters. Okay, for part 3, what they want us to find is, will it pass through the point? Okay, so basically in part 3, what we're looking for is, they're asking you, the defense structure is 150 meters away from the catapult. That means the x value is 150 meters and 5 meters above the ground. So part 3 in simpler English means, will the projectile actually pass through these coordinates? So we need to test this, whether the path actually passes through these coordinates. So let's use the x value of 150. So what I can do is, in my equation, I will substitute in the value of 150. I find that my h is 6. So basically what it's saying here is this, okay, the defense structure, let me just draw it out on my diagram here. This is the defense structure, the defense structure will reach until 150 and 5. However, from the equation itself, when you substitute in x equals 150, you notice that it passes through 150 and 6. It means that actually this projectile will pass above the defense structure. So it doesn't pass through 150-5, 150,5, hence the projectile will not smash the structure itself. Okay, example 12. Okay, for example 12, okay, we are talking about a curved arch that supports a bridge once again can see, okay, that this actually forms a quadratic equation itself. So the first thing that they want us to find is to find the quadratic equation in the form ax minus p x minus q. So be very careful here. Notice that this, right, is not the completed square form. It's actually the factorized form itself. So this is what they want. So what I can do is this. For a factorized form, okay, notice this bridge is 120 meters. I mean, this whole bridge is 120 meters. So what I want to draw your attention to is this. When my x value is equal to 0 here, and my x value is equal to 120. These are the roots of my equation. So if I want to form my equation here, what I can say is this: y is equals to x minus 0. This one comes from this, and x minus 120. So this portion comes from this. Notice I'm missing a constant a here, so I will put in the constant a itself down here. So I get x minus 0, x minus a 120. Now the question is, how do I find the constant a? So to find the constant a, what I can do is I make use of certain points on the graph. So if you look at the graph, certain point means that a point that actually passes through, or a coordinate that actually satisfies the equation. I will know this portion here. Why? If the whole bridge is 120 meters, means that the x coordinate here is equals to 60, and the y coordinate here is 50. So I can actually denote that this point is 60, 50, like this. So if I know that this is 60 and 50, so I can say this: I let x equals to 60, y equals to 50. So when I do this, I substitute it into the equation I formed earlier. What I get is 50 equals to a, 60 minus 0, 60 minus 120. If you solve, my a value is negative 1 over 72. Hence, okay, my function is y equals to negative 1 over 72. Okay, so this is here. X minus 0 can be just simply written as x, then x minus 120. So that is part 1 on how I found the function to represent the x. So if you want to see how this relates to the diagram, actually it is this. So for this arch over here, okay, is represented by this equation or function, just like this. That is part 1. Okay, part 2 is this. If a point on the arch, right, is 10 meters horizontally from O, what's the height of the arch? So in part 2, what they're asking is this. So the point is 10 meters, so my x value is 10. So what is the height of the arch? Y. What I can do here is this. I just substitute it into my equation. So if you remember, our equation earlier is negative 1 over 72, x minus 120. So I will let my x value equals to 10. So y equals to, I substitute in the value of x equals to 10. I will find that my y value is equals to 15 and 5 over 18 meters. Hence, the statement is my height of arch at that point is equals to 15 and 5 over 18 meters. So what this implies is this: when my x value is 10, here I can find that my y value is equals to 15 and 5 over 18 meters. So therefore, at this point, when this is 10 meters, I know that this point here is 15 and 5 over 18 meters above the surface of the water. Okay, now for part 3, another point on the arch is 20 meters vertically is 20 meters vertically from the surface of the water. What's the width of the arch? Okay, be very careful. What they want here is the width of the arch. So when I'm looking for the width of the arch, they're actually asking you how wide is the arch right at that point. So let's just dissect this question first. 20 meters. So what they're saying is at 20 meters, what is my x value here? Okay, again, so at 20 meters above the water, what is my x value here? So now I will just simply go to the next page first. So in part 3 itself, what I have is this. My equation again is y is equals to negative 1 over 72 x minus 120 when my y value is equals to 20. So I get 20 equals to negative 1 over 72 x minus 120. Okay, if you simplify everything, what you should get is x squared minus 120x plus 1440 equals to 0. I suggest you pause the video and try, okay, to simplify this to this. Okay, this would have been learned in your EMAT itself. Then I apply my quadratic equation. So negative b plus minus square root of b squared minus 4ac over 2a. What I should get is this. My x value is equals to 13.524 or 106.48. Okay, now these two values very important, here and here. Okay, 13.524, what does it mean? Okay, back to our diagram again. So I learned that at 20 meters, okay, my x value here is 13.524. It also means that here is 20 meters, here to here is 13.524, here to here also 13.524. So what the question is actually asking you is for the width of the bridge. So the width is actually down here. This is the width they are looking for. So how do I get the width? I take 120 minus 13.524 minus 13.524. What I'm left with is the width of the bridge itself. So for me to get my width of my bridge, so I'll take the width is equals to 120 minus 13.524 minus 13.524. So the width of my bridge will be 93.0 meters. Correct to 3 significant figures. Okay, I will now go on to example 13 itself. So example 13, there's this is about underpass again. Once again, this is a quadratic function. Okay, now write a quadratic function in the form a x minus h squared plus k. So basically, what this question actually wants you to do is to write this out in the completed square form. Okay, so now completed square form actually gives you the what I call the maximum point or minimum point. So what information can we gain from this question? Straight away from the diagram itself, I know that my maximum point itself is when x is 3, y equals to 5. Be careful, this x value is 3, not 6. 6, x equals to 6 is at this point. At the midpoint, here x equals to 3 and my maximum value is 5. So now let me start with this. Okay, so the function is y equals to a x minus h square plus k. I know that my maximum point is 3 and 5. So in the completed square form, y equals to a x minus 3 square plus 5. So basically, I'm just converting this, okay, into this itself. Now, the next important idea is how am I going to find my a value? I know that my function passes through the coordinates 3 and 5, okay, or I can also use when x equals to 0, y equals to 0. y, because over here I know that when x is 0, my y value is also equals to 0. So therefore what I can do is let x equals to 0, y equals to 0. This coordinate satisfies this equation, hence I can use it. So now 0 is equals to a, 0 minus 3 squared plus 5. I find that my a value is negative 5 over 9. Hence, the function is y equals to negative 5 over 9 x minus 3 squared plus 5. Now, find the height of the arch when the width is 4 meters. Okay, again, width is 4 meters. What does this imply? Let me just erase everything. When the width is 4 meters, it means that I have something like this, okay, that is 4 meters. So at 4 meters, all right, the width, I want to find the height here. What can I do here? Okay, 4 meters is important because if the entire arch itself is 6 meters, okay, and this is, I want to find at 4 meters, it implies that these two portions are equal, and if 6, okay, it is 6 meters, all right, okay, here will be 1 meter, 1 meter, and 4 meters. Is that okay? Now, if I have this ready, that means what I'm trying to find is what is the height when my x value equals to 1 meter, okay, what is my y value here. So for part 2 itself, what I'm actually looking for is this, okay, I start my equation, negative 5 over 9 x minus 3 squared plus 5. So when okay, my x value equals to 1, I'm trying to find what my y value is. I find that my y value is 2 and 7 over 9. So this means that, okay, when my width, okay, when the width is 4 meters, the height of the arch is 2 and 7 over 9 meters. Okay, so from the diagram, so it means these are from all our calculations. If the width is 4 meters, okay, here this is 2 and 7 over 9 meters. So that means the height is 2 and 7 over 9 meters. For part 3 itself, what we're looking for is if the truck is 4 meters, so that means the width of the truck itself is 4 meters and is 2.5 meters tall. So earlier I found that, okay, when it's 4 meters, okay, this height is 2 and 7 over 9. However, for this truck, the truck is 4 meters, the height of the truck is actually 2.5 meters. Notice that there's still a gap here and gap here because 2 and 7 over 9 is actually greater than 2.5 meters. Hence, right, the truck, even though it's 4 meters in width, the height is 2.5 meters, it will pass through the arch itself. So to write it out in words, okay, what I can say is this for my part 3. Okay, the maximum height when width is 4 meter is equals to 2 and 7 meter. Then since, okay, 2.5 meters, which is the height of the truck, is lesser than 2 and 7 over 9 meters, hence, right, the truck can never, hence, truck will be able to navigate the underpass. So it won't, the top of the truck will not, destroy the underpass itself. Okay, now, can y'all please go and pause the video, all right, and try 13 before I actually, give you the answers for try 13. And now I'll continue in 3, 2, 1, let's go. Okay, now, So basically is this, what this question wants is for us to write the quadratic function in the form which is the completed square form. So do pay attention to the form itself. So now from this diagram itself, I can actually say that this point here, this is my maximum point, and this maximum point is at 1.5 and 2 itself. So I can actually write out, right, my equation is y equals to a is a constant which I do not know, x minus 1.5 square plus 2. So this is what I've written out here, x minus 3 over 2 square plus 2. To find my constant a, I know that when my x value is 0, my y value is 0 over here. Hence, if I put this into my equation itself, I solve, I get my a value is negative 8 over 9. So the equation representing my arch is this, y equals to negative 8 over 9, x minus 3 over 2 square plus 2. Now, next question is, when the width is 1 meter, all right, okay, they want to find the height of the arch when the width is 1 meter. Okay, so now if you know, okay, you look at the diagram, okay, the whole underpass, right, the width of the entire underpass is 3 meters here. So now if I want to find the width of 1 meter, so 1 meter, okay, out of 3 meters, I minus away the 1 meter, I'm left with 2, then I divide by 2, I get 1. So 1 and 1 now here. So I am trying to find at this point, when my x value equals to 1, what is my y value? So I will substitute it into my equation. When my width is 1 meter, I substitute into the when my width is 1 meter, my x value, as I shown earlier, my x value is 1 meter. I substitute this into my equation. I find that my height of the arch is 1 and 7 over 9 meters. Now, lastly, the last question is, what happens, okay, will the boat that's 1 meter wide and 1.8 meters tall? Okay, so now if I have a boat like this, okay, I draw the boat, okay, so the boat is like this. So the boat, the height, right, when the width is 1 meter, we found that the height is 1 and 7 over 9. Okay, so 1 and 7 over 9, you convert to decimals, is 1.77 meters. However, for the boat, right, the boat will be slightly bigger than the arch itself. Okay, because you see that the width of the boat is 1 meter, but height of the boat is 1.8 meters. So in this case, since 1.8 is greater than 1 over 7 over 9, the boat cannot navigate safely through the underpass, so it will actually crash into the arch itself. So no, this boat, right, cannot pass through safely through the underpass. Okay, and this concludes